API CPD Training Overview for Inspectors. Good day everyone and welcome to this professional development session. Today we will discuss continuous professional development, also known as CPD for certified API inspectors. This session is designed for professionals certified under API 510 Pressure Vessel Inspector, API 570 Piping Inspector, API 653 Above Ground Storage Tank Inspector. These certifications are administered globally by the American Petroleum Institute, commonly known as API. The goal of this session is to review important technical topics that support CPD learning and professional competency for inspectors. We will cover several areas including mechanical integrity in process industries, inspection codes and standards, damage mechanisms, inspection techniques, risk-based inspection concepts, fitness for service evaluations, storage tank inspection, documentation and inspection management. This training session is presented by URGS International Engineering Services Private Limited, an organization dedicated to professional engineering training and technical development. Let us begin by understanding the importance of CPD in the inspection profession. Continuing professional development. Continuing professional development is an essential part of every engineering career. Engineering industries evolve continuously. New materials are introduced. New inspection technologies are developed. Codes and standards are updated. Operational challenges change as facilities age. Because of these changes, inspectors must continuously update their knowledge. CPD ensures that inspectors maintain their competence throughout their careers. Instead of relying only on knowledge gained years ago, inspectors continue learning and improving their expertise. CPD activities can include technical training programs, professional seminars, engineering workshops, industry conferences, technical publications, and structured learning courses. For inspectors certified under the American Petroleum Institute, CPT learning supports professional competency during the certification cycle. Participating in structured CPT training helps inspectors remain aware of code updates, inspection best practices, damage mechanisms, and industry lessons learned from failures. CPT is not only about maintaining certification, it is about maintaining professional responsibility and safety awareness. Industrial facilities handle hazardous materials and operate under high pressure and temperature conditions. A well-trained inspector plays a critical role in preventing equipment failures and protecting people, assets, and the environment. Now let us discuss mechanical integrity and why it is important in industrial operations. Mechanical integrity is the ability of equipment to operate safely throughout its intended service life. Process industries such as oil refineries, petrochemical plants, and gas processing facilities rely on complex equipment systems. Examples include pressure vessels, process piping, heat exchangers, storage tanks, and pressure relief devices. These assets operate under demanding conditions: high temperature, high pressure, corrosive chemicals, and cyclic loading. Over time, these operating conditions can cause equipment degradation. Mechanical integrity programs are designed to detect deterioration before failure occurs. Inspection is one of the most important components of mechanical integrity. Inspectors assess equipment condition and determine whether the equipment can continue operating safely. The responsibilities of inspectors include evaluating corrosion damage, detecting cracks or defects, verifying repairs, reviewing inspection records, and recommending inspection intervals. Inspection decisions directly influence plant safety and reliability. Because of this responsibility, inspectors must maintain strong technical knowledge. This is why CPD training plays an important role in professional inspection practice. Next, let us review the role of codes and standards. Engineering codes and standards provide the technical rules that govern equipment design, construction, and inspection. Pressure vessels are generally designed according to the ASME Boiler and Pressure Vessel Code. This design code specifies requirements for materials, fabrication, welding, and testing. Once equipment is placed into service, inspection is governed by API inspection codes. For example, inspection of pressure vessels is addressed by API 510. Inspection of piping systems is addressed by API 570. Inspection of storage tanks is addressed by API 653. These inspection codes provide guidance for inspection intervals, inspection techniques, repair requirements, and inspection documentation. Codes are periodically updated to reflect industry experience and technological advances. Inspectors must stay informed about these revisions. CPD training helps inspectors review code updates and understand how they affect inspection practices. Now let us examine equipment damage mechanisms. Damage mechanisms are processes that cause material degradation. Understanding these mechanisms is essential for inspectors. If inspectors know how damage occurs, they can better identify potential problems during inspections. One of the most common damage mechanisms is corrosion. Corrosion occurs when metals react with their environment. General corrosion causes uniform metal loss across surfaces. Another form is pitting corrosion, which produces localized holes in metal surfaces. Even small pits can eventually grow into serious structural problems. Another common mechanism is erosion. Erosion occurs when high velocity fluids remove material from surfaces. This often occurs in piping elbow, valves, and fittings. Over time, erosion can reduce wall thickness. Another important damage mechanism is fatigue. Fatigue occurs when equipment experiences repeated stress cycles. These stresses may be caused by pressure fluctuations, vibration, or thermal expansion. Fatigue cracks often start small and grow gradually. If not detected early, they can lead to sudden failure. Another mechanism inspectors must understand is stress corrosion cracking. This occurs when tensile stress combines with a corrosive environment. Cracking may occur even when there is little visible corrosion. Hydrogen damage is also important in refinery environments. Hydrogen can diffuse into steel at high temperatures. This can cause hydrogen blistering or hydrogen induced cracking. Recognizing these damage mechanisms helps inspectors determine where to focus inspection efforts. Let us now review inspection methods used to detect such damage. Inspection methods. Inspection methods allows inspectors to detect defects and evaluate equipment condition. The most fundamental inspection technique is visual inspection. Visual inspection involves examining equipment surfaces for signs of damage. Inspectors look for corrosion, distortion, leaks, cracks, and coating deterioration. Although simple, visual inspection is extremely valuable. Another widely used method is ultrasonic testing. Ultrasonic testing measures material thickness using sound waves. This technique is essential for monitoring corrosion rates. Another common method is magnetic particle testing. This method detects surface and near surface cracks in ferromagnetic materials. Liquid penetrant testing is also widely used. It detects surface breaking defects in metals. Radiographic testing uses X-rays or gamma rays to examine welds and internal defects. Each inspection method has advantages and limitations. Inspectors must select the appropriate method depending on the equipment and expected damage mechanisms. Let us discuss inspection planning and risk-based inspection. Risk-based inspection, traditional inspection programs used fixed inspection intervals. However, modern facilities increasingly use risk-based inspection, often called RBI. RBI evaluates equipment risk based on two factors: probability of failure and consequence of failure. Probability of failure depends on damage mechanisms and equipment condition. Consequence of failure depends on factors such as safety impact, environmental impact, and production losses. By combining these factors, facilities can prioritize inspection activities. High risk equipment receives more frequent inspection. Low risk equipment may require less frequent inspection. This approach improves safety while optimizing inspection resources. Inspectors must understand how RBI affects inspection intervals and inspection planning. Next, we will discuss fitness for service assessments. Fitness for service. During inspections, defects are sometimes discovered. The key question becomes, can the equipment continue operating safely? This is where fitness for service analysis is applied. Fitness for service assessments follow methodologies described in API 579 Fitness for Service. These evaluations determine whether equipment damage can remain in service. Examples include metal loss evaluation, crack assessment, dent and distortion assessment. These assessments help engineers make safe decisions without unnecessary shutdowns. The next is storage tank inspection. Storage tanks are critical assets in petroleum facilities. Inspection practices for tanks are addressed in API 653. Key inspection areas include tank cell condition, roof integrity, tank bottom corrosion, and foundation settlement. Tank bottom corrosion is particularly important because it can lead to environmental leaks. Inspectors are use specialized inspection techniques to evaluate tank bottoms. The next is inspection records and documentation. Inspection documentation is essential for maintaining mechanical integrity. Inspection records should include inspection dates, thickness measurements, corrosion rates, repair history, and inspection recommendations. Proper documentation allows engineers to track equipment condition over time. This information supports maintenance planning and risk assessment. At last, inspection professionals play a critical role in maintaining industrial safety. Continuous learning ensures inspectors remain competent and informed. CPD training helps inspectors review technical topics, understand code updates, and learn from industry experience. Our organization, URG's International Engineering Services Private Limited, provide professional training programs designed to support inspector development. For more information about CPD training programs, you may contact us. Uh, URG's International Engineering Services Private Limited. Our email ID is info@urgseng.com. Our mobile number is +917359458455. Please contact us for CPD trainings. Thank you. If you if thank you for joining this professional development session. Please like, share, and subscribe for more engineering training content. Stay safe, continue learning, and keep advancing your professional career. Thank you.